Good morning, all participants of ICOR 2020. I would like to present my works on effective network flow approach for solving uncapacitated dynamic load sizing problem with time varying cost, presented by Dr. Boonphakdee, เกษตรศาสตร์ University Thailand. The study is interested in applied network flow approach for solving uncapacitated dynamic load sizing problem or UDLSP. Parameter or characteristics of load sizing model can be explained in number one, planning horizon is the time interval on which the master production schedule extends into the future. Include finite planning horizons, dynamic demand, and infinite planning horizon, settling demand. Number two, number of levels in production system include single level production system and multi-level production system. Number three, number of products include single item production planning and multi-item production planning. Number four, capacity or resource constraints in production systems include uncapacitated constraint and capacity constraint. This study is constraint in finite planning horizon. Number five, demand includes static demand, dynamic demand, deterministic demand, and probabilistic demand. Number six, variable costs such as production cost or raw material cost, ordering cost, and holding cost. Includes time varying and constant cost. This study constraint in dynamic demand and deterministic demand and time varying cost. The study is interested in time varying costs. The varying of material costs will obviously affect to the total cost if quantity is great. The holding cost is essential when the quantity of the stocks of each period are greater than the demand in the next period. The ordering cost is important if number of purchasing orders grow consistently. Mathematical formulation of UDFSP can be explained as follows. The first constraint minimizes the summation of raw material and ordering and holding costs. Second constraint, conversion constraint, including the summation of starting inventory and lot sizing equal summation of demand and ending inventory. The third constraint, the limitations of lot sizings. X sub t is the lot sizing. S sub t is number of accumulative periods. D sub m is value of accumulative demands. Y sub t is binary number. If lot sizing is 0, y sub t is 0, otherwise y sub t is 1. Wagner-Whitin's algorithm based on dynamic programming is a famous algorithm for solving UDFSP. They consider constant holding costs and time varying ordering costs. However, they will not consider the effect of production or raw material costs. The author algorithm will still not consider the effect the same as the Wagner-Whitin algorithm. So, network flow approach consider the effects of raw material in total cost. This network indicates node to be the number of the remaining inventory. X is number of available lot sizing. D sub O is the summation of demand at period 1 to demand at period T. D sub 1 is the summation of demand at period 2 to demand at period T. And finally, D sub T is the last demand at period T. The last ending inventory I sub T must be 0. Dynamic programming for searching the shortest path was applied for computing lot sizing, which generates minimum total cost. This algorithm can be explained via MATLAB community by this URL. This slide shows file exchange which contain the proposed network flow algorithm in MATLAB code. This code can be downloaded by using URL in previous page. Cost of networks flow algorithms is verified by exchange Wagner-Whitin problem in 1958. Consists of demand, earning cost, raw material price, and unit cost per unit. This table shows that network algorithms generate processing in period with the lowest raw material price. Network flows algorithms generate processing in 195 units in the first period with the lowest raw material price $10. While Wagner-Whitin algorithms generate 195 units also in first and third period with the raw material price 10 and 12. So network flow algorithms will effectively generate lot sizing with the smallest raw material price. This slide shows the shortcut path with compute by dynamic programming. This slide shows the comparison of algorithm performance when varying demand and raw material price. Network flows to be more efficient than Wagner-Whitin and LP that's based on the Wagner-Whitin network algorithm. Red lines is performance of network flow. Dark lines is performance of LP based on Wagner-Whitin network. Blue lines is performance of Wagner-Whitin algorithm. This slide also show performance of algorithms when varying ordering costs and unitary holding costs. Network flows algorithms still performs to be more efficient than Wagner-Whitin and LP algorithm. Composition times. When lab code of network flow approach must construct a huge square matrix that it has dimension on the summation of demand from period O to demand at period T, demand from the first period to demand at period T, and finally demand at period T. Time complexity of operational dynamic programming to be big O n poverty. That is the limitation of running this course on the Spark format. Therefore, it needs be long time to run these algorithms. When running course with 12 period and demand length on 100 plus minus 20, its computation time is about 3.7 hours. In the other hand, time consuming of running LP and Wagner-Whitin algorithms to be only 1 second. Maximum array size. Owing to limitation of memory available space use case, each course has to generate or array with utilized memory space use must be less than 24 and 397 megabytes. Network for approach course needs memory available space use case to be over 2,500 megabytes, whereas Wagner-Whitin and LP algorithm needs memory available space use case to be less than 2,000 megabytes. The maximum array size of dynamic programming could be achieved on length 200 to 1,000 of dynamic demand in 12 period with 56,754 multiple array size. Nevertheless, memory performance test is depend on RAM of the test computer. Advantage. Time varying cost was considered in management decisions of apparel industry and agricultural products. So, network for algorithm enhanced to decide whether purchasing raw material or not, with the minimum total cost and satisfy demand. Network for algorithms can efficiently overlay UDLSP with zero demand, whereas Wagner-Whitin algorithm fail to run this problem. Disadvantage. Network flow algorithms use huge time consuming and available memory space use due to operating dynamic program with enumeration.